Hello. So today we will be looking at yet another aspect of design for environment. Today we'll be talking about material selection, and primarily material selection for products and processes from an environmental impact standpoint. Now, as you may very well know, the material choice in the case of a product or process is very important. It impacts a lot of things. For example, it impacts the functionality. The choice of the material will decide how functional a product is or the range of its capabilities. But it also impacts other things like how rugged does the product look, what is its appearance in general, and many other attributes like can it be recycled, can it be remanufactured, and so on and so forth. Is it machinable? Is it castable? There are so many things to consider, and so material selection is a very important step. Now, for most design situations, there is a choice of materials that you have. It's not that you got just this one material. And so it could be metallic versus non-metallic. Within metallic, it's ferrous, meaning iron and steel, or non-ferrous, aluminum, magnesium, and so forth. And oftentimes, you have competing options. And so it is a pretty complicated task, choosing the right material for a job. So some of the questions that a designer would ask as a preliminary is they would ask themselves, does the material have the necessary physical properties to do the job, right? That is, to function properly as a product. For example, physical properties could mean something like density, specific gravity. It could refer to the boiling point or the polarity of the material. So these are some examples of physical properties. Then they would ask themselves the question, does the material have the necessary chemical properties, such as, is it flammable? Sometimes you want the material to be flammable because the application requires. Oftentimes flammability is undesirable. Its toxicity, how toxic is the material? Is it soluble in solvents, different kinds, whether it's water or something else? So these are some examples of chemical properties. So these two kind of decide whether the material will do the job, that is the function. Then we ask ourselves, is the cost reasonable? It may meet the function, but it may be priced very highly. So those are certain things we ask ourselves, but that's not all. There's a whole slew of other things that the designer must ask herself or himself. Some of these are, does the material pose an environmental hazard? Is it toxic? Or is it result in global warming potential? Is it a safety hazard? Then they ask themselves the question, is the embedded energy in the material very high? What does that mean? Embedded energy is the amount of energy that a product that you have has in it as a result of processing. So if you are dealing with a steel product in your home, like maybe the refrigerator, right? Because the body panel could use low carbon steel. Well, it's been meaning iron ore. There's a lot of energy required. It's very energy intensive. Then it has to be purified, processed, primary processing, secondary processing. There's a whole lot of processes and a lot of energy goes into it. So the final product that you hold in your hand may have had a lot of energy put into or not. And so if the material has very high embedded energy, it's not as desirable. Then the whole bunch of questions about availability of the material, its abundance. So we could ask ourselves the question, is the material under any supply constraints? It may be a strike in Wyoming or in West Virginia, and it's been ongoing for a year, and you need to look at alternate sources, maybe from Mexico or from Poland. Is a recycled supply of the material available? It's another question. If it is, it's a good thing. And is the material readily substitutable? Do you have a choice B and C that can more or less do the job and are not too badly off economically? So quite a lot of questions to ask. However, in this class, right, since you have had exposure to design and material selection in your undergraduate courses, our emphasis will be on material selection only from an environmental standpoint. So we are looking at environmental hazards and availability of resource as the key aspects for our discussion of material selection. Do bear in mind there's a whole lot from a function standpoint, but we assume that that has occurred in an undergraduate class. So from an environmental hazard standpoint, right, one of the key things to look at, the choice of the material is often limited by the toxicity that it has. So if you have 4 or 5 choices, all things remaining the same, that is, it can do the job and it's aesthetic and so forth, then we choose the one choice that poses the least toxicity concern, right? It has to be non-toxic to human users. So how do you go about knowing this? Well, there are 2 government sources in the US that provide us with a list of toxicity of materials. The first is from US EPA, and it's called the Industrial Toxics Project. So this basically is an agreement between EPA and industries to voluntarily reduce the emissions of certain pollutants. So, such as what? So in your chapter handout, you should find this on the 2nd page, but I have it here. So you can look at these chemicals. What do they include? They include a lot of heavy metals, for example, lead and its compounds, mercury and its compounds. Whether you know anything or not, you're surely familiar with these. When you buy a home, you're always asking about lead-based paints in the home because they are a toxicity concern. Mercury sometimes get released in water bodies, which can pose a serious toxicity issue. But there are also other things here that are organic compounds which are used in solvents and can also pose toxicity concerns. So these are the list of chemicals identified by EPA. So a designer has to just look at this list to see if it is impacted. But we have a much larger and a more comprehensive list from a second source, and this was based on the US Clean Air Act. I think the Clean Air Act goes to 1970 or so, but basically what it is it's a list of about 600 or 700 chemicals which are considered hazardous air pollutants. So it's a long list, as you can see. So when you're considering A, B, C, and D, check this list to see if it's implicated. So as far as toxicity goes, here are some tips about what you may do. Designers need to consider the following. If it seems like the initial choice of material that seems to do a good job functionally, aesthetically, is toxic, what do I do? You can consider substitution. See if there is another choice, B or C, which is nearly as good but less toxic. So substitution, material substitution. The second step is, can we redesign the process? Sometimes when you change the process, it may be accepting of other kinds of materials than was possible earlier. So that's an option. The third thing is, use toxic, sometimes you must use them. Do so only if that toxic material presents a range of properties that you must have for the product. If not, then you may look at other choices. Even if a material is deemed to be necessary and we know how to process it so that it doesn't cause any problems to the employees, we still have the problem of what do you do at the end of the process? You have this collection of chemicals, toxic. What are you going to do with it? You need to have an answer for that. And you need to consider the potential for future restrictions on the use. It could be the state of Texas or the federal government that can tomorrow, a year from now, 2 years from now, place restrictions. So you need to be thinking about all of this when you're dealing with toxic materials. So this discussion pertains to environmental hazards.